Hello there, this is Wellington with PX5, and today I'll show you how to work with memory partitions using PX5 RTOS. So in this video, I'll show you the partition pool APIs, then I'll run a 4 minutes demo, and then I'll share some resources. The partition pool APIs we'll see in this presentation are not part of the standard POSIX pthread APIs. They're actually part of the PX5 RTOS extended APIs. That's the reason why all of them have the PX5 prefix. The partition memory is allocated as a fixed size memory block as defined when the partition pool is created. Dynamic and variable length allocation is also available, but we cover that in a different video. In this quick scenario, we have a partition pool with 2 blocks taken and 2 blocks free. So it should be very simple to support this new request, given that we have 2 blocks available. If an allocation request is made when there are no memory partition available in the pool, the calling thread may suspend, depending on the exact API used. When a memory partition becomes available, the first suspended thread will be resumed. Let's take a look at the APIs. Before we can use a partition pool, we first need to create it. We do that by calling the partition pool create API, passing the handle of the partition memory pool, then any optional attributes, the starting address of the memory area for the pool, then the number of bytes in the memory area for the pool, and finally the size in bytes of each memory partition in the pool. Then we can check the return for errors. Once the partition has been created, we can allocate. We do that by calling the partition pool allocate API, passing the handle of this partition pool, then the destination pointer to return the allocated memory partition, and then the number of bytes requested. Even though this is fixed size, we require this information for precaution. And of course, it must be less than the partition size of the specified partition pool. And then we can check the return for errors. And finally, after use, we can release partition pools by calling the partition pool free API. And to that, we only need to pass a pointer to the previously allocated partition memory, and then check the return for errors. All right, let's see these APIs in action. As always, main starts running by creating variables, thread handles, and a memory area. Then on line 9, we start PX5 RTOS by providing a random number for pointer data verification, memory area, and the size of that memory area. This will convert main into a thread running at the default priority of 16. Next, to create a partition pool, we need to provide a handle to this pool, any parameters we need, in this case null, the starting address of the memory area for the pool, the number of bytes in the memory area for the pool, and finally the size in bytes of each partition in the pool. See, the partition pool has been created with 1024 bytes free. Next, to create another thread, all we need to pass is the handle to the new thread and the entry point for this new thread. Here we can see the child thread has been created, also with the default priority of 16, same as main. It is ready and waiting to run. Back to main. Main will now yield, allowing child thread to run. Child is now running and will increment its counter, now at 1, and then it will try to allocate 1024 bytes from the partition pool. Well, since this was available, it is now taken from the pool and it will yield back to main. Let's expand the while loop inside main. Now main will increment its counter variable, now at 1. Main will also try to allocate 1024 bytes from the pool, but since that space is not available, main thread will be suspended and child will be able to resume. Note that the main was added to the waiting list on the partition pool. Child thread will now free all the memory allocated before, With that, memory is free and main is no longer blocked. Child will now yield again. So that main can resume with the memory allocation complete. It will check the return call of the API and yield again. So now child thread will increment its counter again, now at 2, and will try to allocate more memory. Child thread is now blocked because there was no memory available and it is on the waiting list for this partition pool. Giving main the opportunity to run again and the cycle will start all over again. Well, that's the demo we had for today. Now that we covered the basics of working with partition pool, you might want to take a look at these additional APIs like the partition pool destroy, which will destroy partitions pools specified in the API call, and also the partition pool try allocate. This API call will try to allocate a block from the pool, and if there's nothing available, an error is returned. There are several other partition pool related APIs. Please take a look at the PX5 RTOS user guide for more information. If you want to get started, make sure to check our website at px5rtos.com. You can email us with questions, requests for information, or a quote at info@px5rtos.com. Thank you for your interest.